Hi, this is Steven Martinez and this is my AP problem number 9. The graph below shows the results of the titration of a 25 milliliter sample of a 0.1 molarity solution of a weak acid HA with a strong base 0.1 molarity NaOH. For A, we have to describe two features of the graph above that identify HA as a weak acid. So HA is a weak acid since its equivalence point is above a pH of 7, which means it is a strong base weak acid titration. Also, HA is a weak acid since its starting pH without any NaOH added is about 3. For B, we have to describe one method by which the value of the acid dissociation constant for HA can be determined using the graph above. So we can determine the value of the acid dissociation constant for HA by finding the pH of HA at the halfway point, since at the halfway point pH is equal to pK. Then we just find Ka by using 10 to the negative pKa, and we found the pH. For C, on the graph, sketch the titration below that would result in 25 milliliters of 0.1 molarity HCl were used instead of 0.1 molarity HA. So the starting pH would be negative log 0.1 is equal to 1 pH, since the molarity of the HCl is 0.1, and the pH at the equivalence point is 7 because it is a strong acid-base titration. And after the equivalence point, the pH curves would be similar to the first pH curve. So this would be our sketched pH curve. For D, a 25 milliliter sample of 0.1 molarity HA is titrated with 0.2 molarity NaOH. We have to find what the volume of a base must be added to reach the equivalence point. So we do sort of a M1V1 equation with liters and molarity. So we multiply 0.25 liters with 0.1 molarity is equal to 0.2 molarity times X liters. So we get X is equal to 0.125 liters, so we must add 12.5 milliliters of base to reach the equivalence point. For part 2 of D, the pH at the equivalence point for this titration is slightly higher than the pH at the equivalence point in the titration using 0.1 molarity NaOH. Explain why. So the total volume in the titration with 0.2 molarity NaOH is smaller at the equivalence point, which means the molar concentration of the conjugate base of HA is larger compared to the concentration of the conjugate base of the 0.1 molarity NaOH at the equivalence point. So the pH of the 0.2 molarity NaOH is higher.